Okay, so apparently I wanted to do more vertical line tests, so they're pretty fun. So what do we think on this one? Do you think that's a function? Yes, you can draw a vertical line any place, and it's only hitting once. Now you might say, well, what about like right here? Yeah, but you know, it really is only hitting one place. It's just, you have to go with that it's moving up a little bit and a little over there. What about this one? No, that overlaps right there. It doesn't have to be three places, you know, but as soon as it hits one place. What about this one? What do you think? Yes, that one's okay. You can draw a vertical line any place. It's only going to hit once. Okay. What about this one? No, because, you know, it's a circle. Yeah. Okay. A little bit about graphing, dots and arrows. So sometimes we'll have a graph that looks like this, okay? So this is there's an infinite number of ordered pairs here. Okay, they're all along that arch, okay? But it's starting and stopping. These closed dots are included. Closed dots are included. Okay, so let me give you some numbers here. Let's say this is -2 and this is 2. And then let's say this point up here is 4. Okay? So I'm just trying to give you some numbers here. If you were going to write the domain and range, the domain would be from -2 to 2. You'd have to use interval notation. So the domain would be all those points in there. And then the range would be from, oh, let's say 1 there. Okay. So 1 to 4. Okay, so it looks something like that. Okay. Now let me draw another picture. Let's say I have 1, 2, 3, 2, 3. And let's say my graph looks like an open dot here, and then it's going straight, and then it's going to go, well, pretend like it kind of curved down there. Okay, like that. All right, that's fine. The open dot means that that point is not included. So if I were doing the domain would be from open parenthesis -2 to 3 with a closed bracket there, okay? Because I'm including the 3 but not the -2, right? Open dot and closed dot. The range would be from -2 up to, I don't know, it kind of looks like 1.5. We'll say 1.5. And that would get a closed bracket, okay? By the way, that's a function. Okay. What if you had a graph something like this? And we'll make that a 1. Sorry, a positive 1 there. And let's have a 2 here. And we're going to have an open dot and off that way. Let's say you had that graph. Well, first of all, I don't know if you can see it very well. Is it a function? And the answer is yes, it's a function. Because you can draw a vertical line and it only hits in one place. Because the open dot there and the closed dot there, that's a function then. So it's not 2 points there. Now, how would you write the domain? The domain would be, now we see how these arrows here, they're continuing on forever and ever in both directions. So actually my domain is all real numbers here. You can think about that for a little bit. The range is what's a little bit trickier here. So I'm going from -infinity up to 1. So I'm going to include that. So -infinity up to 1. Did I say -1? It's a positive 1. Bracket, right? Because I'm including a point there. But then I'm going to have to skip over some numbers, these numbers that are in between here, and go from 2, not including the 2, to infinity because it's moving on up, okay? Because again, you have the arrow here. So that's probably more information than you need, but just wanted to talk a little bit about what arrows mean, open dots, and closed dots.